In this video, we're going to do a pre-lab for a lab called the spectrophotometric determination of the percent copper. I usually call it pennies in a stream. So it starts with learning something called Beer's law, which is A equals ABC, which is not particularly helpful. So the little a is something called molar absorptivity. The little c is concentration, which is molarity. We know what that is. B is a path length. And the capital A is absorbance. So what this formula tells us is that absorbance is directly proportional to concentration or molarity. When one gets bigger, the other gets bigger. So what is absorbance? Well, we have these instruments called a spec 20, and what it will do is it will shine light through a solution. The solution needs to be colored. Okay, our solutions are going to end up being blue. The darker the color, the more light it will absorb. So if you have a solution that's pretty dilute, kind of a light blue, it will have a small absorbance. It will only absorb a little bit of light. If it has a higher concentration, or it's darker blue, it will absorb more light. So the two things we need in this formula are just the idea that absorbance and concentration are directly proportional. We're not actually going to worry about these other two things, because we're just going to take the idea that they're directly proportional and make a graph. So if I've got a bunch of solutions, I can graph them, absorbance versus concentration, and since they're directly proportional, I should get a straight line. So I can have y equals mx plus b, where y is your absorbance, m is your slope, x is your molarity, and your y-intercept. Solutions come from. So we're going to call these standard solutions because we're going to know what their concentrations are. So in our volumetric flask, we're going to have a 100 milliliter volumetric flask, all right? And in it, you're going to put a certain amount of copper that you're assigned. Different groups will use different amounts of copper. And then we're going to add some nitric acid. Since it's concentrated and it's pretty dangerous, I'm actually going to add it. But when we do that, this solution takes place. Copper reacts with nitric acid to make copper 2 nitrate, which is blue. That's why we have a blue solution. It also makes NO2 and water. NO2 is a toxic gas. It's brown and it's poisonous. So we will be doing this in the hood. You can't breathe in NO2. A little teeny tiny bit's not going to hurt you at all, but we can't have it generated in the room. So you got to make sure you stay in the hood. So every person or group is going to make up a couple of these standard solutions. So we'll have this kind of list of who's doing what. We should have 8 groups. So group 1 will be responsible for making up 2 standard solutions. One with about 0.05 grams of copper, one with 0.65 grams of copper. So we'll just assign groups. You'll notice that a couple groups are only making 1 standard solution, and they're going to be responsible for a penny, which we'll talk about in a minute. So, for instance, if you're group 1, you would take 0.05 grams of copper and weigh it right into your flask. Okay, this will be a 100 milliliter flask. You put it right on the scale. You'll weigh out your copper as close to 0.05 as you can, and make sure you record it. So, you might record something like 0.053. That's, close enough. Okay, and then I'll come around in the hood and I'll add some nitric acid, and a really cool reaction will take place, and you'll make some observations. Okay, and then when it's done, what you'll do is you'll take, you're going to add some water to it, kind of swirl it and mix it, add a little more water, swirl it and mix it, until finally you get the meniscus right on the bottom of the line there. Okay? And not until you're totally at the line here will you take your stopper and put it in there. Okay? And then you mix this by inverting it. So we can show you in class, but basically you just put your thumb over the stopper, you turn the whole flask upside down, you go back and forth a few times, and then it's all mixed. All right? And then you're going to take a little bit of this solution and you're going to put it in a cuvette. A cuvette is basically kind of a square test tube, but it's designed to fit into our spec 20, and it's going to record the absorbance for us. Okay, so we'll know you'll be able to, from your grams of copper, you're going to be able to figure out the molarity of your solution. And now we've got the absorbance, so we're going to be able to make a graph of a bunch of absorbances versus molarity. So in class, or before class, I'm going to share this spreadsheet with you. So each group will put in their names, okay? Actually, your names will already be there. You'll record the mass of copper you used, okay, and the absorbance you recorded. Okay, don't fill these out because we're going to use the spreadsheet to do all the work for us. So we don't have to do 14 calculations, okay? We'll use a spreadsheet to complete the calculations to get to molarity, and then we'll put this into a graph, which will look something like this, absorbance versus concentration, and we'll get hopefully a nice straight line. You notice we were talking about pennies. So two groups are responsible for a penny, either a new penny or an old penny. Pennies before 1982 were mostly copper around this really tiny, tiny core of zinc. Pennies after 1982 were mostly a big core of zinc with just a thin, thin coating of copper. This was done because zinc is much cheaper than copper. So the groups that have the copper and the pennies, what you're going to do is you're going to weigh your penny, okay? Then you're going to put it in a beaker, all right? And then we're going to add some nitric acid, okay? Again, in the hood, all right? We got to be in the hood again. Things are dangerous. And you're going to make your observations, and then you're going to get a solution, okay? But we can't just fill this to the line because a beaker is not as accurate or precise as a volumetric flask. So what you're going to do is you're going to pour this, you're going to transfer this into your volumetric flask, add a little water, swirl, pour it in there, add a little swirl, water to the beaker, pour. So you're going to rinse a few times to make sure there's no blue left. Okay? And then your volumetric flask, again, you'll fill it to the line and mix. And you'll have a penny solution now. So again, you'll be in a volumetric flask, but this will be for one of your pennies. So again, you'll transfer a little bit to a cuvette, and you record the absorbance. All right? So now we've got this graph that we made. About this graph, should we include the 0.00? If my solution had 0 concentration of copper, what would the absorbance be? So think about that, and I'll ask you in class, should I include this 0.00? Okay, so we've got our graph. We're going to generate a best fit line using the computer. Okay, so absorbance is slope times molarity plus the y-intercept. So for the pennies, they won't get graphed. You'll take the absorbance for your penny and plug it in here, okay, and then you'll solve for molarity, because you'll know the slope and the y-intercept and the absorbance, okay? So we'll solve for molarity. And then once you've got your molarity, that's moles per liter, multiply it by the volume of your flask, and you'll have moles of copper, okay? So this is going to tell you how many moles of copper was in your penny. And then if you go ahead and multiply that by the molar mass of copper, it's going to tell you how many grams of copper were in your penny, and then you can do part over whole and find the percentage of copper in your penny. And then you repeat it for the other penny. So we'll be able to find the percentage of copper in a new penny and an old penny. So we're learning how to make solutions. We're learning what Beer's law means. We're learning how to use spreadsheets to make graphs. And we're using it all to find the percentage of copper in a new penny and an old penny.